Good morning, everyone. Am I audible? Hello?
Yes, ma'am.
Okay. Okay, I'll share my screen. Sharing. So, I told you last class, like we are going to do some problems on, the stability of structure. But when I saw the syllabus, right, when we're talking about the syllabus, so we need to talk about the loads, loading, etc. Those things also about the materials. So I'm thinking like I'll be doing the properties of materials, then the loadings according to the Indian standards, which IS codes you are going to follow for your loadings. Okay, so those things, dead loads, life loads, whatever it is, so that things will cover first of all. After that, we'll go to the stability of structures, like how to find out whether it is stable, determinate, indeterminate. All those are important. So we'll be talking after we go to these basic like material properties, the is codes, etc. Okay, so if we talk about in the first class, I think the last two classes which we took, there we were talking about all the roles of different designations, different job titles. We had talked about those things. So coming to the main structural portion, like what are the different properties of different materials. These are some of the things, like what were different types of materials are there. We had in your fourth semester, fourth year, fifth, no, yeah, on the fourth semester in the materials we had talked, but here the IS codes also you will know for which is what in details. Okay, so let's start. So basically, the materials which are to be known to you people are what? Your cement, fine aggregates, coarse aggregate, water, admixture. These things are to be known by you people, because these are the things only which you're going to use in your structural members. Okay, for the construction of your structure, any kind of member you are developing or constructing. Okay, so cement, you know already what is your cement is your binding material, you know. Okay, so cement is your binding material. Fine aggregate are what? Your fine aggregates are your void fillers. Okay, that means obviously when you have some when you're mixing with your aggregates, you have to there will be, when you use this coarse aggregates, right, in your concrete, when you use your coarse aggregate for providing the strength, like your aggregates, like your stones, the aggregates, coarse aggregates are what? They are nothing but your the small, big, and those rock broken, that is your stones. So fine aggregate is what? When you have those aggregates, coarse aggregates, they will be different in shapes. So suppose you're making mixing, you're making concrete. No, what will happen if when you're using the, this is a, in zooming the portion materials, what we are getting, these are suppose your coarse aggregate. So obviously to feel these, right, to fill these portions, to fill these gaps, okay, what you need to do, we have to use fine aggregates, which is your nothing but your this one, sand. So when you're using coarse aggregate with cement, cement will be binding all these things, that is your coarse aggregate, your fine aggregates, which are your sands, here inside, all this will be sands, sand particles. So aggregates, to fill the voids, these voids present, what you need your fine aggregates. And to buying these all the materials together, you will need your cement. Okay, and also water. What water will do? Because water is going to hydrate the cement and controls the workability and the strength of these mixture. Okay, so admixtures, sometimes we also use admixtures to our concrete so that we modify the property of the concrete in fresh and hardened state. Okay, so these is your basically a concrete, that is your coarse aggregate made up of your coarse aggregate, fine aggregate, cement, water, right? But we nowadays we also use admixtures so that to to increase the strength of your this concrete or to change the property of your concrete. Okay, fresh concrete. So some of the admixtures, like if I tell you, there is lime, we can mix with your concrete lime to enhance your property of the concrete. You have natural, if nowadays in the research world, there are so many natural waste materials which are used to, to as an admixture to increase the strength and the stability of your sorry, the strength of your this concrete. Okay, so admixtures like waste materials, if we talk, they are they can be your RHA, that is your rice husk ash, rice husk ash. It can be, these are your waste material, that means admixtures. Okay, not only waste materials, chemicals are also there, chemical admixtures are also there. Rice husk ash, lime you can use as admixture, you can use fly ash, you can use as admixture. There are different materials. When you come to the seventh, eighth semester, you will know that you need to do your project works, right? So when you do your project works, if you're doing on your soil, you can do the stabilization of your this soil, or the cement also you can do with the cement. Nowadays so many research works are going, like what type of admixtures are used, and suppose we use RHA to our this concrete, how this is affecting the property of the concrete, that you can do in your research work. Then lime, fly ash, there can be fibers also, different fibers are also used nowadays as an admixture or filler. Okay, so these are some of the researches going on, and then the admixtures are also used. So these are some of the admixtures. Now the first one being, if we talk about the cement, if we talk about the cement, here in the clause 5 you will see of IS 456. This is very important, like about the cement, the properties of cement, the constituents of cement. Okay, all these things you are going to get in your IS, that is Indian Standard 456 code. Okay, this is very important, you have to, you must know these things. Okay, this is very important. That means what code, on which IS code is your properties of this material cement is mentioned. That is in the Indian Standard Code, that is your IS 456. You have to always remember, because this IS 456 you're going to use in your designs also. Okay, so IS 456, in the IS 456 clause number 5, you're going to get your properties and the details about your cement. Okay, so yeah, before we go to these, I think you people must I want to inform you people that you have to have your IS code 456. Okay, but since you're actually, when we were doing the offline classes, in the class we always, all the students had to have their IS code with them. Okay, this code book, IS code book is very important, and this is always because all the things regarding your RCC structure, reinforced concrete structure, is mentioned in your 456 IS code 456, and that you had to have with you. And also in your future, also in every works, you will need your this IS 456. So you must have a
We
hard
have to.
copy of your IS 456. Okay, but I think now, since we are doing offline, if you have the soft copy of this IS 456 also, it is okay. Um, can you yourself get this IS 456 in soft copy? If you can, I think you'll get in the net also. Huh. or else I think I'll share in the group if I think I have the soft copy. Yeah. So remind me, I'll give you this IS 456 or the soft copy of this IS 456 in the group. Okay. So, uh, but when if the class starts, the physical class starts, you will have to have your hard copy of this. That is the you have to have your this IS 456 book. Okay, and always you have to bring your design class because you everything is there in your IS 456. Everything means with respect to this IS 456 only we are going to design, we are going to take some specifications, different types of specifications are will be taken by your IS 456. From this code we are going to know everything like what are the uh, how much dimensions, how much thickness, how much quantity, all these things about the tests, etc. Everything is in your Indians according to your Indian standard IS 456. We have to do that. Okay, so I'll share if I forget, you remind me. Like I have to share this IS 456 soft copy with you people. Okay. So now talking about these from the clause number 5 of IS 456, what does that mentions? Like these cements are manufactured by what? Mixing calcareous limestone, argillaceous clay materials in definite proportions. It contains the following oxides. Okay, these about the cement you have already in your fourth semester also you have read many things about your cement. So talking about your cement, in according to your IS 456, I think whoever had prepared and also for your exam purposes you have gone through these things, but still for the sake of this subjects, chapter wise we need to complete the properties of the materials also. So we'll go in short like in the IS code what it is mentioned in clause number 5 that these are the constituents of your cement. Okay, that is your calcium oxide. The first one is your calcium oxide, which is the percentage of calcium oxide present in your cement is 62%. Okay, this gives this mainly gives this constituent gives what? Your strength and soundness to cement if excess cause unsoundness. If this is above 62%, that means if it is in your cement, this quantity of this is more than 62%, that means 70 or 80%, then it will become your cement is going to become unsound. And I think in your fourth semester also we have discussed about your these tests. You have already discussed about the soundness test, workability, then again your fineness test, all those things we have already discussed. You can just go behind, go and check those things. So calcium oxide, then we have your silicon dioxide, then you have your aluminum oxide, then we have your Fe2O3, which is your iron dioxide, then magnesium oxide, okay, sulfur dioxide, then we have K2O, potassium oxide, then we have Na2O, which is your sodium oxide. Okay, so these are your, and the percentage, the maximum percentage of the maximum percentage of the material which is there in our this is the calcium oxide is in maximum. Okay, in the you this is the basic you have to know like the cement, since it is a binding material, right? To bind this coarse aggregate, fine aggregate, okay, so cement is a binding material. How it binds? It will bind the maximum constituent of the cement is what? Calcium oxide is the maximum percentage, that is your 62%. Then we have 22, and the lowest one is your what? Lowest one is your sodium oxide and your potassium oxide, that is 1%. So most important is your calcium oxide, the maximum constituent of cement. This is one of the important question which you should know, like cement constituents of what? Cement calcium oxide. Maximally more than 60% in the cement is your calcium oxide, then is your silicon dioxide, then we have your aluminum oxide. Okay, so what is the remark that is given for your calcium oxide is gives strength and soundness to cement. If it is more, you know that it will be unsound, your cement will be unsound. Then SiO2 also gives your strength. It accesses the delay settings. That means the setting time, your silicon dioxide SiO2 will delay the setting time also. Okay. Now this is causing your Al2O3, that will cause your setting and lower clinkering temperature, lowers the clinkering temperature. That means at low temperature you can do this a mixing of this cement materials together. Then we have Fe2O3. This will give the color and the hardness to cement. Okay, so you can be asked in some of your competitive exams like which constituent of cement, or which is the which causes the color in a cement, the coloring property in the cement, which is caused by what? That is caused by your Fe2O3 and MgO, magnesium oxide. Okay, and the strengths are caused by what? Given by your calcium oxide and silicon dioxide. So we have this is also so these are in very less quantity required. Okay, so these were your constituents. Now, if we go to below, we'll see it is fed into a rotor. How it is prepared, that is mentioned. This you have already gone through in your fourth semester, like how it is prepared. Your cement, it is fed into rotary crane 1500 degree. So 1500 degrees Celsius. Then we have is obtained, which is cooled and then ground into fine powder. Okay, gypsum is added to prevent the quick setting of cement. Okay, otherwise, what will happen when you make it make it into fine powder, and then if it adds to the water is also added to it, what happens? It will get set fast. So gypsum is added to prevent the quick setting of your cement. 3 to 5% gypsum is used. Okay, so the cement thus obtained contains four major compounds known as your box compound, which is your, these are your four most important compounds. Okay, which a cement constitutes. That is your tricalcium silicate C3S, dicalcium silicate C2S, tricalcium aluminate, and tetracalcium aluminoferrate. 50% by volume of cement is your tricalcium cement. This is also very important. Okay, so the main compounds which are present in your cement is what? Tricalcium silicate is the main one, which is more than 50%, which is more than 50%. Then comes your dicalcium 60%, 25% tricalcium aluminate, and tricalcium aluminoferrate. These are also important with respect to your examination point of view. For any kind of exam, if you said like what are the different compounds, the most important and the maximum which is there in the cement is what? The most important compound is your tricalcium silicate. Next is your dicalcium silicate. Then comes your tricalcium aluminate, and then 10%, the least one is your tetracalcium aluminoferrate. Okay, remember, you will remember this, like what is the a maximum which is present in the cement. The most important compound is your tricalcium silicate. Okay, C3S, and then dicalcium silicate, tricalcium aluminate, and then tetracalcium aluminoferrate. Now, talking about the hydration of cement. So, talking about the hydration of cement, when cement mixed with water, the box compound react. That is the box compound. Just now we have talked about the box compound. What are your box compound? Your box compounds are your tricalcium silicate, dicalcium silicate, tricalcium aluminate, and tetracalcium aluminoferrate. Okay. So those were your Bosix compound. The four Bosix compound we have done. with water. When cement mixed with water, the basic compound react with water. That what reacts with water? Those four compounds will react with water and heat will be generated. Okay, which is known as your exothermic reaction. This heat will cause your hydration. Okay. So that hydration was caused by what? That four compounds. When that four compounds, box compound react with water, then your hydration forms and your cement will become start binding the materials. Okay. So this is a heat of hydration responsible for initial strength development of cement less than 3 days, which is your this one tetracalcium aluminiferrate and the tricalcium aluminiferrate. Okay, so early strength development of cement 3 to 7 days. The strength of the cement which uh, the cement gains from within 3 to 7 days is what that is given by your tricalcium silicate. Okay. So initially, when the hydration takes place and when your cement starts gaining strength, the initial first 3 days is what is your that is given by your tetracalcium aluminiferrate and your tricalcium aluminate. Okay, and the three within 3 to 7 days, the strength which the cement gains is what your that is given by your that is by your tricalcium silicate. Okay, the late strength that is from between 7 to 20 days, and you people know like how many days your concrete requires to attain its desirable strength. That is the maximum 28 days. The compressive strength, characteristic compressive strength is gained by within 7 to 28 days. That means till 28 days it gains its ultimate strength. Okay, so that is the late strength after 7 days is given by your this done by your this dicalcium silicate. Okay, we have this is the performance characteristics of ordinary Portland cement. That means the different properties we have already talked in fourth semester, like the fineness property, consistency, all those things. Okay, still we just see in short, like fineness, this will measure the size of the cement particles, how much fine is your cement particle. Okay, this is the specifications according to IS 456. That is only less than 10% by mass of cement shall be retained on 90 micron. Air permeability test, specific surface of cement should be this much. Okay, these things you will get in your IS codes. You can, so it's important to have your IS code with you 456 so that you know these things in exam also you can check. Okay, so consistency, next is your next characteristics is what of a cement is your consistency. Now, the consistency means what? To determine the quantity of water required to prepare the cement paste of the standard consistency. This we have already done in fourth semester. How much water is required for better workability. That is your consistency, nothing but your consistency. And you had used your Vickers apparatus to do that. Now this is the according to IS code. Again, these things you will get in your IS code. The cement paste is consistent if you're that plunger when you're using this Vickers apparatus. Just this is a revise just for your fourth semester which we had done, the PPTs you had prepared, right? So that was what the consistency how you had determined using this Vickers apparatus and your plunger when it penetrated 33 to 35 mm from the top of the mold, your that was your consistency. Generally that consistency should be between 26 to, this is very important, 26 to 33%. Generally your consistency is how much? It should be between 26 to 33%. Otherwise it is less workable, you can say, or you can say it is not a consistent. Okay, poor cement quality you can see. So these are basically testing the cement qualities. Also you can check through these consistency between 26 to 33%. Okay, then next is what? Setting time. You had also talked about your setting times. Hmm. Then where is our okay. Okay, so we have the setting time. Another one is the initial setting time, final setting time. This also by Vicat apparatus, Vicat mall needed is required. These things we had done in food again. So the specification according to IS code is what? It should be greater than 30 minutes, should not be less than 10 hours. Oh, sorry, should be less than 10 hours. To prepare the paste, water use is 0.85 p. This already we had done in fourth semester. Okay, should be greater than 30 minutes. Your initial setting time is 30 minutes and your maximum should be 10 hours. Okay, soundness test by Lee Chatellier's test. This should be the distance between indicators should be less than 10 mm. Percentage increase in length of the specimen 0.8%. Now the strength, average strength, use of mortar, compressive strength we had already checked. Okay, so according to IS score, what it says like your strength should be 453 grade. I think in your exam, the Viva also I was asking you about your grade of cements. What are the different grades of cement? You could not say some of you. So these some of the grades in your IS score again you will get 53 grade, 43 grade, 33 grade of cements are there. Different grades of cements are there. Okay. So that means what? Your 53 grade of cement means what? Your strength will should be greater than 53. That means minimum strength is how much? 53 Newton per mm square. Then megapascal. Then we have 43 grade. Sorry. Then we have 33 grade. That means your cement compressive strength should be minimum 33 megapascal. Okay. Now, when we the next material we were talking about the we had discussed was what coarse aggregate. That is your aggregates. Now, that means coarse aggregate means what? That under coarse aggregate we have those aggregates which we are using, not sand. Okay, we are using the aggregates. So aggregates are what? According to this, you will get in your IS 456 clause number okay, 5.3. Okay. These clauses you can go in your IS code and check. These properties will be all written there only. That will be specified there. If you have the IS code with you in examination, you can also check in your exam when you sit with the IS code. You can check these properties also. Okay, like what are the specifications according to IS code 456 in clause number 5.3? What it is given? Fine aggregates, coarse aggregate. There it is mentioned that fine aggregates, your particles should be between 0.075 mm to 4.75 mm. This is very important. Generally used rebus and manufactured. So for your concrete, what you use your aggregates, then you use cement, aggregate, water, right? So that aggregate is what? That aggregates are your either it can be fine aggregate, that means your sand, coarse aggregate, that means your normal that stones which you use the aggregates, okay, of different shapes and sizes. So, so for concrete, what you have for concrete cement, aggregate, water. And aggregates are what? Fine aggregate, coarse aggregate. Fine aggregate is your sand, coarse aggregate is your those stones. Okay. So now simply you cannot take any fine sand, right? So fine aggregate, right? So IS code, the Indian Standard Code 456 suggests in clause number 5.3 that it should be between your fine aggregate should be between 0.075 mm to 4.75 mm. Okay, if your particle is either greater than 4.75, if it is greater than 4.75 it will not come under fine aggregate, it is no more a fine aggregate, it is a coarse aggregate. Okay, so coarse aggregates are what? Coarse aggregates are those the size of which is above 4.75, the particle size is above 4.75 mm. Okay, so these is important, like this is important because in your soil also, when you are doing with soil in your soil also you will have these things like sieve analysis we do, we with the help of that sieve sizes you will know that which particle is retaining on which sieve size, right? So I think you was doing transportation material testing levels there. These things did you do in your transportation lab?
Ma'am,
Hmm?
our transportation subject just started
Hello.
now in this semester.
Okay. So you will get these things, okay, in your transportation also, because in the transportation lab you will be testing the aggregates, aggregate flakiness, then the crushing strength of the aggregates, the hardness test, all those things about the aggregate, the all those things you are going to do in your transportation lab. So before that, in your this materials also, according to IS code, you have to know that this is how much. If your particle, suppose you are taking any particle, suppose you are taking some stone, okay, stone you are taking, and also you are taking some crushed stones, okay, some are very big in shape, like suppose some of the aggregates are big in shape, okay, and some are crushed and very small, small aggregates are there. So now these particles, how you will define, like, or how you can say like which particle is coarse aggregate and fine. Obviously, when you see with your eyes, you can say that these are big members, these are big particles. So these are your aggregates, coarse aggregates. When these are small, so fine aggregate. But suppose I said you these are crushed stone. Now you cannot just simply say like these are this comes under fine aggregate, or this is since this is the crushing crushed stone, so these are coarse aggregate. No, you can't say. Why? Because these fine aggregates will also behave like your fine. Sorry, these crushed aggregates will also behave like your filler in your voice, like I told you in the very beginning. Your sand is going to behave as a filler between the voids of these coarse aggregates, the big aggregates, right? So when you have this crushed aggregates, now when you with the help of sieves, when you do the testing with the sieve sizes, different sieve sizes, you are going to take different sieves. With the help of different sieve sizes, when you pour the aggregate and this particles, when you give here and shake it, what will happen? There are different sizes of aggregates are there. Suppose this is your 4.75 sieve size. Suppose this is 4.75 sieve size and rest are the different sizes, and the bottom is your 0. Suppose 0.075. Okay, our meeting is going to end, whatever. So when your materials, these particles are passing through this 4.75 that means these are considered to be fine aggregate. These small particles, suppose I have uh, uh, given here for sieve size, for particle distribution sizes. We want to know, now we have given here. Suppose this was small, this has passed. This was this particle was small, it has passed. But these particles, these are these two, this one and this one, this blue color ones, these have retained. They are not passing through this 4.75 This has retained here only. But these were small crushed stone. These passed through. This passed through this 4.75 So that means what? So that means these two are your fine aggregates. But these are retained here, so it can be considered to be coarse aggregate. Okay. But this normally and generally, what are your finding is sand, because sand particles, you have seen sands are very small particles. They are obviously less than your this 4.75 all this this were aggregate you had done the sieve analysis here. So some of the aggregate particles may remain or retain above this 4.75 sieve size, and some may pass, some may pass. Okay, but the sand, the sand is very small in size. So when you give the sand here and try to do the sieve analysis, obviously your sand is going to, because the sizes of this sieve is large, right? The sizes are large, 4.75 mm. Obviously your sand particles are less than your 4.75 mm, so all are going to pass through this 4.75 mm. So that are called your sands are called your fine aggregates. Okay, sand is your fine aggregate, and the coarse aggregates are nothing but your the stones or the aggregates normal. Okay, so what is happening? Array? Okay. Okay, so these are hard, but the fine aggregates, that is basically your sand, they are found in your river sand, manufactured sand. Then we have the nominal for coarse aggregate. These are very hard. Obviously, the stone chips, I was telling you. So the nominal maximum size of aggregate should be less than one fourth the minimum thickness of the member. In case of heavily reinforced section, nominal maximum size of aggregate should be clear distance between bars minus 5 mm, whichever is smaller. Okay, so you see, obviously you have to use your aggregate, right? Because for concrete, what you need, the three things I told you: cement, aggregate, and water, right? And aggregates are what? Fine, it can be fine aggregate, it can be coarse aggregate. Okay, so you might be thinking like which aggregate to use. Suppose you're making a building, which course aggregate you are going to use, and suppose you are doing for transportation road purpose, you are making a road, you are constructing a road. Now what is that aggregate which you are going to use? So there are specifications given to you in your is code. For this also, the is code 456, in clause number 5.3, you will get the specification. Is code, the Indian standard code, specifies that the nominal maximum size of your aggregate should be how much? It should be less than one fourth of the minimum thickness. Okay, wait, just give me a second. Okay, so these was your IS code. Nominal size should be how much? This is very important. In your IS code, you will get this. Nominal size should be less than one fourth the minimum thickness of the member. Okay, it's like the member, whatever member you're making, whether it be whether it be your column, beam, slab, etc. Okay. In case of heavily reinforced sections, like heavily reinforced sections means like for bridges or too many reinforcements you're using, then the maximum size of the aggregate should be lesser of these two. That means the clear distance between bars you're